Hello, in this video we'll generate the Pascal triangle coefficients using the Taylor-Maclaurin series sum expansion and the LINEST polynomial regression. We begin with the binomial series where it is 1 plus x to the power c, where the value of c ranges from, in this case, we'll have 0, 1, 2, 3, to 8. So our value for z will be data validation of this series. And save. Now we have 9 values to choose from. Next we generate the data set. So array formula 1 plus x to the power n, c to the power c. So if we change the value of c to 2, that's x squared. 3, 1 plus c x cubed. So we'll chart this using scatter chart. Insert chart and generate the trend line. We use scatter chart. Our trend line will be polynomial raised to the power 8 because our maximum here is 8. So when we raise it to the power 8, that means there is no degree of freedom. And that's our equation, and we show the r squared. Here our fitness of the curve is 1, meaning it's perfect. So if we change this to 1, so our curve it's a straight line, and we have the coefficients 1 and 1, but they should be 0 because this is already too small. 3.13 times 10 to the minus 16, that's very small. All these are 0. Next, we use the Taylor-Maclaurin series sum to generate the same data set. And it is equal to array formula, series sum, that is summation of a times x to the power n. So x to the power, x raised to the power starting from 0, an interval of 1. That's x to the n. And the coefficient will be this range. So if we change this, then we can work on the coefficient. So it is array formula, combine c, comma, n. So this is no good. If we choose 8, we're good. But if we choose 7, it's no good. So I have to fix this. So again, this is equal to array formula. This time we put if error, combine c, comma, n. And if this is 0, if it is an error, then we put 0, and it should be okay. Now we're good. So if we have 8, perfect. We go 4, we're perfect. There's no error. Next, we generate the trend line of our expansion. We use the polynomial to the 8th degree. And you show the equation as well as the r squared. They do match because they have the same, they don't match in the at the higher degree, but they are on the same line. We calculate these values of B0, B1, B2, B3, B4 using LINEST. But we already generated the Pascal triangle coefficient. So 1, 4, 6, 4, 4, 1. If we change that to 3, there's a Pascal triangle, the coefficient 1, 3, 3, 1. So this is a Pascal triangle coefficients. Now we generate the LINEST, calculating the coefficients, the regression coefficients. We begin with the power, so of the 1 comma x matrix. So transpose of this range. So that's because we're leaving no degree of freedom. So the rows should be equal to column. So that means no degree of freedom. Now we can generate the 1 comma x matrix. So RA formula of the x values raised to the power 0 to 8. So we have the 1 column, x squared column, x cubed column, x to the 4th column until x to the 8th column. Now we can use LINEST to generate the regression coefficient. So LINEST data y and data x. Likewise, we also use LINEST on the expansion. LINEST data y and data x. So the Pascal triangle coefficients in the regression matrix matches to the Pascal triangle coefficients of the expansion. Change this to 4. Now we have Pascal triangle coefficient 1, 4, 6, 4, 1. And in our trend line, we have 1, 4, 6, 4, 1. And this is considered as 0 because these are very small. So 1.86 times 10 to the minus 13, 1.73 times 10 to the minus 14. These values are very small. So this shows the use of Taylor-Maclaurin series sum and LINEST polynomial regression to generate the Pascal triangle coefficients of a binomial series in Google Sheets.